The historical movements of objects play an important role in today's society. We record the movements of sporting players, animals in ecological experiments, and even weather phenomena. Through advances in consumer technology, data sharing initiatives, and computer vision, these movements are becoming increasingly accessible in computer-understandable formats. Access to this information could provide opportunities for new insights. But first, we must be able to make sense of this new wave of information. One way of understanding this type of data is to replay the movements like you would a movie. Here we are replaying mouse movements. A path begins when a user clicks their mouse and ends with the next mouse click. Notice that as the number of paths displayed increases, we lose the ability to make out the details of individual paths. What we need is a way to select a subset of the entire dataset. Researchers have developed a number of solutions to this problem. Some researchers use textual queries to specify the criteria by which points are selected. Others have designed specialized algorithms to identify objects that exhibit certain properties. We have opted for an approach that is simpler, at least from an end user's perspective, and general, in the sense that it is not targeted at any specific domain. Our approach has a user construct a filter from regions. In this example, the point must be contained by the region to be shown in black. Now the point must intersect each region at least once. Finally, the point cannot intersect any red regions. These regions can be combined together to form more complex filters. Let's have a look at a hurricane dataset to see how it works. Consider that we are only interested in the hurricanes in this region of the world. We construct a region surrounding that area and set it so that it only shows hurricane tracks that are contained by its bounds. Although greatly reduced in number, we are still left with a large number of hurricanes. Maybe we are interested in the hurricanes that pass through this area. We can further refine our criteria by requiring hurricane tracks to pass through another region. Let's say of these, we want the hurricanes that started in this area. Again, we construct a region, but this time we adjust the timeline of the region so that it only applies to the start of the hurricane's lifetimes. Finally, we may want to clean up the remaining hurricanes, so let's add a negated region that discounts any hurricane that passes through it. Now we have whittled down a dataset of around 6,000 hurricanes to just a few that meet our criteria. We can use another application to further process the information. Alternatively, we can summarize the subset in terms of the average length of the paths, average duration, and so forth. That concludes our short demonstration of region-based filtering. Although we demonstrated our approach with a hurricane dataset, we think that it could have applications to many different domains. Feel free to contact us if you have any queries, and thank you for your time.